right, today's lesson is on circle terminology. Hopefully, you've already filled out your 2 journals, and so you have a pretty solid understanding of the pieces and parts of a circle. A circle is a collection of all points in the plane that lie a fixed distance from a fixed point, known as the circle's center. 2 terms that you should already be familiar with from earlier grades are the radius and the diameter. A third term that we want to introduce is that of a chord. So a radius is any line segment drawn from the center of a circle to any point on the circle. So I'm just going to do some labeling here. So segment AB, segment AC, and segment AD are all radii. A chord is a line segment that has both of its endpoints on the circle. So segment DB is a chord. Segment DC is also a chord, but it's a special type of chord. A diameter is a chord that passes through the center. So DC, this special chord, is also known as the diameter. So list 3 segments that represent the radii. Well, I already said those. Segment AB, don't forget your segment bar over the top. Segment AD, and segment AC. Notice that the center of the circle, A, is always the beginning of my name of my radii. Give a segment that represents the diameter of this circle. So the diameter is represented by the chord DC. What is the relationship between the length of the diameter and the length of the radius? Well, half of segment DC equals the radius. Or I could say that 2 times AD equals DC. List all of the chords in the circle that are drawn. Well, I told you the chords, those I highlighted in orange, segment DB and segment DC. Explain why triangle DAB must be isosceles. Well, we know that radii, wherever they're drawn, are congruent to each other. So AB is congruent to AC, is congruent to AD. So if I think of the triangle DAB, I see that I have 2 congruent sides, and that's the definition of isosceles. So segment AB and segment AD are radii, which means they are congruent. Therefore, triangle DAB has 2 congruent sides, which means that it's an isosceles triangle. In exercise 2, circle M. So we name a circle based off of its center. So let's just sketch us a circle. Circle M has point A located on the circle such that AM is located on the circle. So I'm just going to call this A. Is segment AM is 2x plus 7. If the diameter of circle M is 74 units, so if the whole diameter is 74 units, then what is the value of x? Well, remember that if segment AM is 2x plus 7, segment AM is a radii. So 2 times the radius equals the diameter. So 4x plus 14 equals 74, which means 4x equals 60, which means x equals 15. All right, next page. When two different points lie on a circle, they divide the circle into two distinct portions, each of which is called an arc. Arcs, like segments, are named by their endpoints with one complication. So in the diagram of circle O below, O is the center, points A, B, C, and D all lie on the circle. So name a minor arc, which remember minor arcs have less than 180 degrees. Major arcs, which are greater than 180 degrees. And they have to have points A and B as their endpoints. So a minor arc is arc AB. We use this symbol over the top of it to represent an arc, arc AB. A major arc would be arc ADB, which can also be named arc ACB. That's our little complication. So arc ADB or arc ACB. So what's the complication? When you have more than 3 points within an arc, you just have to choose the two endpoints and 1 point that lies in between them. 1 point that lies in between them. So arc ADB and arc ACB are the same arc. These are actually representing the same arc. Name a minor arc and a major arc that have AC as their endpoints. So minor arc, AC. Major arc, ABC. Now notice that there's only 1 point that lies in between A and C on the major arc, so I don't have to choose any other name for that. Arcs will play a very important role in circle geometry, although they can certainly be given a physical length as their direction. Their measure will represent how many degrees around the 360 rotation they represent. To define this, though, we must first define a central angle. So central angles of a circle are any angle that has the center of the circle as its vertex. We typically designate the angle by using 2 points that lie on the circle and the circle's center. So circle B is shown below with various points located on it. Which angle is a central angle? Well, first of all, the central angle has to have B as the vertex. And remember, whenever you name an angle's name, you name an angle by the endpoint, the vertex, and the other endpoint. So if we want a central angle, we know that the vertex has to be B. And the only option for that is angle CBA. The only option for that is angle CBA. So it has the vertex at the center of the circle. Its sides also are radii. That's another key feature of a central angle. Its sides are radii. Now that we know what a central angle is, we can define the measure of an arc. We say that the measure of an arc is equal to the measure of the central angle it intersects. So if angle ADB has a measure of 112 degrees, so angle ADB has a measure of 112 degrees, then arc AB is also 112 degrees. So the measure of arc AB is also 112 degrees. Well, what about the measure of arc ACB? Well, that's the whole other half of the circle. And I know that a circle contains 360 degrees. So 360 minus 112 equals the measure of arc ACB. 360 minus 112 is 248. So 248 degrees equals the measure of arc ACB. And that's your lesson. So your homework is pages 11 and 12.